Um, okay. So photo deflection, pictures look great. Looks like lights are getting dimmer as you go down. And then series versus parallel. So let's see, what do we notice? Group one. So what did you notice, group one?
I guess we noticed that the more light bulbs there were, the dimmer that the light bulbs were because the resistance was kind of spread out with multiple light bulbs, or there was more resistance because there were more light bulbs.
Mm-hmm.
And then because of that, there was less compass deflection. And then I think putting the light bulbs in series, I think it was series where they're not directly connected,
Mm-hmm.
was better for resistance, and then you had less resistance, and then more compass deflection.
Cool. Group two. You don't have your blurb on there, but what did you guys get? That's Chris, Elliot, Ruby, and Tate. Observations. Can you guys turn on your cameras, please?
I'm pretty sure we were group 3.
You are right. I misread. Breakout room two was Dan, Lowell, Lucian, and Marin.
Oh, well then we wrote it as group 2 or group 3, but apparently. But we were noticing that the tall light bulbs like use up more energy than the rounder ones do.
What do you mean by that?
They like the tall, wait, I forgot what we said. Wait.
No, that's the reason I'm asking, Marin, is because that is going to be to the core of your challenge for challenge 9, right? Like week 9 challenge. That's going to be like your ultimate challenge. It's going to be to figure out an experiment to demonstrate that which one of the two light bulbs, the round or the tall, the round or the long, has the most resistance. So that's an interesting. So if you found that it uses more energy, I'd love to know why and how you know that.
Dan, I think you were talking about that. Do you want to? I think you could explain it more.
About the light bulbs and resistance.
The long versus the round bulbs.
Oh, what's it called? The round bulbs have more resistance. They take up more current to power. And then the other ones, they take up less current, so they have less resistance, and they also are less bright if given the same amount of power.
Okay. So something about the amount of brightness, right? Something about the amount of brightness and the amount of current. We'll get back to that. The question is, we don't have, like, for a given light bulb, right? So if we compare like a series circuit with like 1, 2, 3, or 4 of the same light bulbs, we know that brightness is directly correlated to current, right? You guys all demonstrated that. What we don't know is whether we can make the same assumption for round versus long. And that's not a given that we should be able to make that assumption, right? In terms of brightness, in terms of like, does the more brightness mean more current, right? That's something that we don't know. Group 4, what did you guys find?
Our group found that the more light bulbs we used, the smaller the deflection. So we added more light bulbs, the deflection decreased each time.
Okay.
We also noticed, similar to the other group, that the bigger bulbs, or not the bigger bulbs, the taller bulbs tend to take up more energy, and the reason we figured this out is because we noticed that the deflection was smaller. And
Interesting.
what that maybe tell us. Also, another thing we noticed, you had to use 2 batteries to power 2 taller light bulbs or like longer bulbs, whereas you can power 2 round bulbs with just 1 battery. So maybe there's something going on there.
Cool. So what you found is, so it sounds like what you're, so again, I'm just repeating just to make sure I understand. What you're saying is that you have found that for an equal number of batteries, right? For equal number of batteries, you get a brighter bulb
Yeah.
for the round ones than you do for the long ones.
Yeah.
Again, the question remains whether should we, can we compare, does the difference in brightness equate to a difference in current? And that's the thing that we don't know yet, we haven't established. Ramsey.
So I noticed that the long light bulb has longer lines that lead up to the
Mhm.
light, which causes it to light up.
Mm-hmm.
So wouldn't that mean that it needs more current in order for it to light up because it has to travel through something that's larger than the smaller light bulb?
That's an interesting question. What does the class think about that? So that's interesting. Ramsey said he noticed that the length of the filaments, or the length of the conduits that lead to the filaments, is longer in the tall bulb than it is in the short bulb. Question: does that going to make more resistance or not? And some of you actually asked that same question in your discussion on the discussion board on Wednesday, sort of like asking, if you had one wire versus 2 wires versus 3 wires with 4 wires in series, does that make a different resistance or not? Right? That's an interesting question. Yeah, Renzi.
Well, I don't know if the wires are like in relation to like the straw problem that was on the homework, but I definitely noticed that it took like 4 seconds for me to blow out all the air in 4 straws, and while it took like 20 seconds for all my air to blow out in 1 straw.
Interesting. Anybody else found that had that observation? Yeah, Isabel?
Well, I was just gonna say on the Google Doc, it said like under the straw description, it said like you should be seeing that because like the air has more places to go. So that's the same thing with why the parallel light bulbs were brighter because there were more places for the energy to go versus the 2 series, like they all had to go the same direction.